Diffraction. So, why can you hear around a corner, but you can't see? Well, because waves bend around corners, but some waves bend a little better than others. So, you can see here, water waves bending around an island. You can see that sound waves go through a doorway, but you can't see through it. And like we saw in class, light will diffract when put through a small grating. So how does this work? Well, the longer the wavelength, the sharper the bend, the bigger the angle that it moves at. When the wavelength is smaller than the obstacle, no diffraction occurs. In that case, it just reflects. So if you have a marching band outside, say for a parade, and you're blocked by the line of sight due to buildings, which instrument will you hear first? Well, so say you have a piccolo and a drum. The piccolo is pretty high-pitched, so it's got a short wavelength. The drum's low-pitched, and it has a long wavelength. Because the high-pitched sound doesn't diffract very much, because it's not larger than most of the obstacles it encounters, it's actually not going to be able to be heard until just before you can see it, usually. So you're going to hear the drums first. It's not because they're louder, it's because they're deeper or lower pitched. So we talked at the beginning of the unit about things we kind of wanted to learn about, and some of you guys asked about animals using various things with sound in order to communicate or hunt or find their way around. So a couple of animals that use diffraction are elephants and bats. For more information, go to the physics classroom site that's linked to at the end of the lesson.